Assalamualaikum warahmatullahi wabarakatuh. Thank you, committee, for accepting me to present our research with titles Influence of Reactive Ion Etching Time on Fabrication of Porous Silicon on Silicon 110 Substrates. My name is Suryana, and Masud is my student from Department of Physics 11 Maret University. And my colleague Osamu Nakatsuka from Department of Materials Physics, Nagoya University, Japan. The outline is started from introductions to conclusions. In introductions, I will show why I use the porous silicons as a photoanode in die solar cell. Then, in experimentals, I conduct the fabrication of porous silicon using reactive ion etchings. In the result and discussions, I will show several data consist of scanning electron microscopic, detect profilometers, 4-point probe, and reflectance UVVs. Finally, our talking is closed by conclusions. Until now, energy is supplied from petroleums, coal, and gases in the world. This energy are named as renewable energy sources, which is a limited amount in the world. So, the energy will decrease with increasing time. Therefore, we have to find another energy to overcome the limited amount of unrenewable energy sources. That is named renewable energy. One of the renewable energy is solar cell. Solar cell consists of generation 1 is a solar cell based silicon box, and then generation 2 is a solar cells based silicon thin film. Due to generation 1 and generation 2 have high efficiency and high cost, researchers from developing country propose the generation 3 that is named organic solar cell or dye sensitized solar cells. Although dye-sensitized solar cell still has low efficiency and also low cost, several parts can be improved, like titanium dioxides, dyes, electrolytes, platinum as counter electroda. Therefore, there was opportunity to improve efficiency. In this research, we focus on a modified dye-sensitized solar cells. Modified means the ITO photoanode is replaced by a porous silicon. Which has aims to improve the light trapping, dye loading capacity, anti-reflective, and internal surface area, so that the efficiency of dye-sensitized solar cell will increase. This slide is practical steps from preparations until characterizations of porous silicon samples. Substrate use N-type silicon 110, photoresist deposit on silicon 110 using negative photoresist, and spin coats using spin coating in the range for 500 to 5000 RPMs and prebakes at 90 degrees Celsius for 90 seconds. And then photolithographics using photomarks, and then expose UV lights for 8 seconds, and then post-bakes at 110 degrees Celsius. Finally, immerse in developers solvents, consists of NMD3 and DI waters. The next, the samples put inside reactive ion etching reactors, the gas source using CF4, and radio frequency powers at 10 watts. Etching time is varied from 10 to 40 minutes. And then the samples is cleansed using sulfate etched and peroxide etched solvents. Finally, the sample is characterized using SEMs to observe morphology of porous silicon, 4-point probe to calculate the resistivity, depth-profilometers to measure depth and diameters of porous silicons, and finally transmittance UVPs to obtain transmittancy of samples for each etching times. Okay, this is SEM image. All same image show the size and shapes of the homogeneous pores of porous silicons for each etching time. From depth-profilometer, the depth and the diameters of porous silicons are obtained. Both depth and diameters increase with increasing the etching time. 4-point probe. 4-point probe, the current and the voltage of porous silicon can be obtained, and those data are calculated to obtain the resistivity value for each etching times. Resistivity increase with increasing the etching time. Also, it is concluded the pore identic as defects inside the porous silicon will cause high resistivity. To prove that the porous silicon can be used as a photoanode in dye-sensitized solar cell, the reflectance measurement is carried out using UV spectrophotometer. The reflectance decrease with increasing etching time. Decreasing reflectance means that many photons are trapped inside the porous. Therefore, the porous silicon can be used as anti-reflective in dye-sensitized solar cell. Finally, the conclusions as follow. Porous silicon with varying etching time successfully form homogeneous. For size, for depth, and resistivity increase with increasing the etching time. Reflectance value decrease on UV lights range with increasing the etching time. Thank you. Assalamualaikum warahmatullahi wabarakatuh.